Okay, common resources. First up, what is a common resource? Resources in common, another way to state the same thing. A resource in common usage has the two following features. They are non-excludable in consumption and rival. So notice that this is different from a public good. A public good is non-excludable and non-rival in consumption, whereas a common resource is non-excludable and rival in consumption. So let me give you some examples. The examples include open pasture lands where cattle can be grazed, so you can let them wander freely in the open pastures to feed, and then collect them all up later and use. Ocean fisheries. Ocean fisheries just means, the large areas of ocean which are open to to anyone who wants to take a boat out there and fish off certain coastlines in certain regions where fish are known to migrate. That's another example of a common resource. And river irrigation systems, the problem is the following with rivers. One thing you can do with a river that's nearby your farm is you can divert some of the water from that river to use for irrigation, to water your crops, right? And lots of people have done this over the centuries to provide water for their crops. But if you take water from the river upriver, and then somebody else takes water from the river upriver, and then somebody else a little bit further down the river takes water for their farm, then this river that winds through a large countryside, by the time the river gets to its final destination in the ocean, most of the water might be gone because it's been taken away. And the farmers who are at the lower end of that river are going to be negatively affected by the decisions made by the people at the upper ends of the river. Okay? Again, this is an example of a product or a good which is non-excludable and rival in consumption. So let me explain the details of that. Think about fish. Fish being caught in the ocean fishery. Fish is rival because the fish that's taken out of the ocean is going to be used by that fisherman, taken to the market and sold and used as a private good. Once that fish is taken out of the ocean, it's not available for anybody else to use. Okay, and that's why the ocean fishery is rival. Same thing with the pastures. Pastures, when you allow your cattle to graze on the pasture land, it eats up the grass. And if you put too many cattle, it's going to eat up all of the grass. And the more grass disappears, the farther and wider your cattle are going to have to roam in order to find food, and your resource is going to be diminished. So the pasture land is rival in consumption. And the same thing with river irrigation systems. Like I just explained, using the river upstream is going to prevent that same water from being used for irrigation downstream. And so the use of the river is rival in consumption. They're also non-excludable, or at least it's difficult to exclude individuals from using these particular things. How do you monitor the individual boats that go out into the ocean and fish? How do you know who's out there and so forth? Same thing with pasture land that's open, that doesn't have fences around it. How do you monitor who's using it, whose cattle are out there? Or river irrigation systems. You'd have to wander the entire river and find out where water is being diverted in order to identify exactly who's participating and taking river water for irrigation systems. It's not that it can't be excluded completely. It could be, but it's going to be costly in order to try to prevent and monitor individuals that are trying to use that particular resource. Okay, and that's what makes these resources common, in common usage, and why we call them common resources. Okay, so let's go forward. What we're going to do is create a common resource problem. Okay, so this is just a constructed example that's going to highlight the principles involved here. Suppose we have a town that has two occupations. The occupations are a rancher and a farmer. The rancher has got a herd of cattle, and they need to feed their cattle on some open pasture land nearby. Farming, on the other hand, there's open acres available near the community, and you can plop a house down on a piece of land and you can farm the land easily. Okay? Let's imagine that farmland is plentiful. There's lots of it, but good pasture land is scarce. It's harder to come by. Now, we're going to make up some numbers. These are just fabricated numbers made up just to make an example. So suppose farming provides an income of $10 per day. No matter what you do, rain or shine, winter or summer, plop yourself on a farm and you're going to make $10 a day every day all year long. Okay, so let's imagine that's how much you can make as a farmer, and it doesn't change. It's always the same, immutable. Now, we're going to make ranching a little bit more complicated. Ranching is going to provide income to the rancher, but it's going to follow this schedule, this formula. And this formula is I for income, and N is the number of people in ranching. And we're going to say that the amount of income that a rancher gets is going to be negatively related to the number of people that are actually grazing their cattle on the pasture land. Okay, so the more N is, if you have 2 or 3 or 4 or 5 ranchers, the cattle is going to eat up more of the grass faster, and it's going to have some negative impact upon your income ultimately. Your cattle is not going to grow as fast, it's not going to get as fat, you're not going to make as much meat, all of that is going to happen. All right, so let's look at a schedule. Here's our schedule where N is the number of ranchers that are devoted to ranching. The income of ranchers is given by this formula right here in the first column at the top. And then we've got the farmer income, which is going to be the rancher's opportunity cost. So a rancher can either ranch and make money, or if they don't want to do that, they can fall back and become a farmer and assure themselves $10 per day as a farmer. So let's think about what will happen here if we allow private individuals to make decisions about ranching and farming in this simple community. Okay, first thing, let's suppose we ask, let's say we start off with the base case of everybody is in farming, and we have an individual who's considering going into ranching, just one person. So let's do this sequentially. If one person goes into ranching, N is 1, and so the income is going to be 50 minus 5 times 1, which is going to be equal to 45. Okay, so using the formula and the N of 1, we get the number 45. So that's $45 per day. That's going to mean you're going to have one rancher out there. The cattle is going to get really fat. You're going to be able to sell it for lots of money on the marketplace. You're going to do much better than a farmer. So we'd expect one rancher would certainly, nobody else is acting, one person is going to jump in and become a rancher. But what about another person? Second person says, hey, maybe I should become a rancher too. We'll do this sequentially again. Well, if you add a second rancher, it's going to diminish the rancher's income by another $5. But still, 2 ranchers together each are going to make $40 each. That's better than 10. And so 2 ranchers would be inspired to enter. One more step. A third rancher. Well, a third rancher diminishes the income again by $5 in total. So every rancher now, 3 of them get $35 each. But $35 is still better than the 10. So therefore, the third rancher would enter. We go on. The fourth rancher would enter because 30 is greater than 10. The fifth rancher would enter because 25 is greater than 10. The sixth rancher because 20 is greater than 10. The seventh rancher because 15 is still greater than 10. And then we finally get to the 8th rancher, who's going to diminish the ranching income to a total of $10 per rancher. But then there's no incentive for the 9th rancher to enter, because the 9th rancher is actually going to diminish the rancher's prospects and make it worse than being a farmer. Nobody wants that. So they're going to stop. Private decisions are going to lead to a decision where 8 people will go into ranching. The remaining 12 people will remain as farmers. And this would be the private outcome or the equilibrium that we can expect in this very simple economic situation we've set up. Okay, everyone with me? Now, let's take a look at what's best overall for the community or the town of this 20 people. Okay, and in order to figure out what's best, we're going to calculate the incomes in total of the farmers and the ranchers in each of these different scenarios, 1 to 9 different ranchers. Okay, so for example, in the first row here, with one rancher income is $45 per person. There's only one rancher, so N is 1. So we're going to take rancher income times the number of ranchers, that's 45. We're going to take the remaining number of workers, which is 20 minus 1 in this case. That's going to be 19. We're going to multiply that by 10 to get 19 times 10 is $190. We add these 2 up to get the last column here. Total rancher income plus farmer income, that's FI, is going to sum up to $235. Okay, so that's if one rancher goes into business and they stop there. What if 2 ranchers go into business? 2 ranchers is $40. 40 times 2, the N, is going to be $80. Now we've only got 18 farmers, so 18 times 10 is 180, and that's going to give us a total of 260. Now we do that all the way down the list, each row by row, and we get income going from 235 to 260 to 275 to 280, and then it starts to come down. Now notice, 280 is the biggest number here on the right. The best outcome for the community overall in this scenario is actually to only have 4 ranchers working and ranching, making $30 each. That's going to generate a much larger overall income. You're going to have farm products to eat, and you're going to have lots of meat to enjoy, and you're just going to be, according to this, wealthier as a result of that particular outcome than you would have been if you let the market be free and let the ranchers enter according to their own individual desires and preferences. Okay, if 8 ranchers enter the industry, we're only going to end up with total market welfare being equal to 200 as opposed to the 280 if we reduce the number of ranchers in the industry. Okay, so the best outcome is for 4 people to go into ranching. Now, one of the negative aspects of this is that that's actually going to result in an income inequality. The ranchers are going to be fundamentally wealthier than the farmers, $30 per rancher rather than $10 per farmer. Okay, and the equilibrium, if you could somehow inspire 4 ranchers to go into ranching and stop there, that might be sustainable for a short period of time, but you're going to have the potential that profit seeking could actually induce the entry of new ranchers. So you might have a rancher who says, well, we've sort of agreed to just 4 ranchers, but you know, if I could bring my herd of cattle and I could hide them around the mountain on the other side where the pasture's pretty good, then maybe I can get away with it and I can actually make, you know, $25, which would be if 5 ranchers enter. Okay, and that's better than $10. So there's lots of individuals who would still be inspired to try to become ranchers in this particular scenario if we stopped at 4. So the equilibrium here is unstable, we would say. It's not likely to be maintained through the goodwill or self-interested behavior of the individuals that are participating in the marketplace. I want to throw in one other issue here before we get to the next step. And the next issue has to do with the potential unsustainability of ranching. Now, by unsustainability, I mean that if you set enough cattle out into an open pasture land, that's limited, you know, you can't go forever. The pasture land isn't infinite in size. That eventually the cattle is going to eat up all the grass. And if you put them all out there at the same time and they eat up all the grass before new grass can grow, you're going to diminish the resource to an extent that you've got no grass for any cattle to eat, right? And you're just not going to be able to maintain your cattle industry at all. Now, let's suppose the more ranchers there are and the more herds of cattle that are put onto the pasture land, the more likely it is for that pasture land to end up becoming unsustainable, that it's just going to run out of grass to provide for cattle at all. Well, let's make the red marks here, and let's draw a line right here between 5 and 6 ranchers. I'm making this up, so where is this number coming from? I made it up, just to illustrate this point. If the cutoff between 5 and 6 is the breaking point between sustainable grazing and unsustainable grazing, then it's like saying if we put 6 or 7 or 8 or 9 ranchers into the pasture land, we're going to use up this resource. It's going to diminish to such an extent that nobody's going to get anything. None of the ranchers are going to be able to operate in the future if we end up with 6 or 7 or 8 or 9 ranchers operating on the property, on the pasture land. Okay, it's just going to be unsustainable. All right. If that were to occur and we let the private outcome be the equilibrium in this market, we're going to end up with something that's called the tragedy of the commons. And the tragedy of the commons is this result where the fishing grounds are overfished, the pasture land is overgrazed, the river is overtapped to use for irrigation, to the extent that it just diminishes completely and it's not available for anyone to use. That would be a tragedy, because the resource is no longer available. And it's a tragedy caused by this commons problem. The fact that ranching is non-excludable in consumption, but rival in consumption at the same time, generates this potential for the tragedy of the commons to arise. All right, and that's what tragedy means. The tragedy is reaching this unsustainability of the resource and the inability of it to produce in the future, and that's what might come about when private decisions are allowed to be made in this particular marketplace. So, how do we solve the problem? Well, one way to solve the problem is with government intervention. The government can come in and regulate the market for pasture land or the ocean fishery or the river irrigation systems. And they can actually specify who's allowed to operate, how many people are allowed to operate, what are the rules that should be applied. Governments can step in and try to adjust what the equilibrium will be by implementing some sort of government policy. Now, there are lots of different types of government policies that can be used here, but I'm going to introduce a very simple one that's going to work in our particular situation here. So here's the policy. The government's going to come along and just say, we're going to place a tax of $20 for every rancher that's operating. So if you're a rancher, you've got a $20 tax you got to pay the government. If you're a farmer, no taxes are being collected. All right, well, what will ranchers do? We're still going to let them make private decisions, maximize their profitability, enter ranching if it's profitable to do so. And then we might ask, okay, should the first rancher enter the ranching industry? And the answer would be, well, $45 is what they would earn if there's only one rancher. Take away the $20 tax, and we're going to end up with each rancher or that rancher getting, what, $25. Well, $25 is greater than $10, the income to the farmer. So the first rancher would enter. Second rancher would enter too, because $40 per rancher minus 20 still gives them $20, which is greater than 10. 35 minus 20 is going to give you $15, which is still greater than 10. And 30 minus 20 per rancher is going to be equal to $10, which is just equal to the income you're going to earn as a farmer. But if we say, should a fifth rancher enter into the ranching industry? Well, 25 minus 20 is now going to be equal to $5, and $5 is less than what you can get as a farmer. So, don't enter. The fifth rancher has no incentive to enter the market now. So what's going to happen? 4 ranchers should enter the market because that's in their best interest to do so. Ranchers fall to just 4 rather than 8. This is their private optimizing decision now. Tax is going to be $20 per rancher. And so $20 times 4 is going to give you the $80 of tax revenue, which is going to be collected by the government. More on that in just a minute. Now, total income is also rising by $80. So one thing the government has facilitated here is that it's been able to increase overall income in the society by exactly the amount that it's collecting in tax revenue. Now, what does it do with this revenue? It can take that revenue and it can spend it on public goods, for example. It can provide parks for the community. It can build roads. It can do things that's going to help the general public facilitate its day-to-day life. All right, and that's going to generate benefits over and above what the individual farmers and ranchers are making. I've got regulate with fishing quotas. If you're in a fishing industry, there's another way in which you could do this. Instead of setting a tax, you could actually just say there's a quantity limit to either fishing. You can say, well, we're going to let fishermen go out and fish, but we're going to limit their catch and say they can only come in with a certain amount of fish to try to prevent the overfishing. We could do the same thing with pasture land. We could limit the number of ranchers to just 4. Just make it a regulation. There shall be only 4 ranchers in this pasture land. And then force the outcome in that particular way. So there's other ways you can regulate and kind of adjust what the outcome in this market would be. The tax is the simplest one in this particular context. So let's go forward with that. Oh, there's one other thing I have to mention here. By virtue of putting the tax into place and moving the number of ranchers from 8 up to 4, the government is also solving the tragedy of the commons problem. They are preventing this common resource from being overutilized and led to an unsustainable outcome in the near future. Okay, so government policy is not only raising income, but it's raising income for the future as well, and helping to sustain a viable production process long into the future. So it's really clear in this particular example that the government intervention is actually improving economic efficiency. The outcome, the market is doing much better. More happiness is being generated to more people because the government came in and taxed the ranchers $20 each and generated the optimal provision of this common resource. Okay, so what do we learn from this? Some lessons. First of all, private profit incentives will often induce overusage of the common resource and potentially cause a tragedy of the commons result. That's what's trying to be avoided here. Don't overuse the resource, don't cause the tragedy problem to occur. And private incentives are directed in that particular way, can potentially lead to that overusage of a resource. And that's a particular problem. The tragedy, again, is that the resource is depleted so much that it can't sustain the herds of cattle in the future. So what you're doing by overproducing is basically cutting off your future potential production because of that. And that's where the tragedy comes in. Now, the governments can correct the problem. We just saw that with an appropriate taxation scheme. So if they measure the problem, figure it out, they can actually come up with an answer that's going to eliminate the tragedy problem and actually increase overall community income as a result. But now I want to talk about a little bit about non-government solutions and talk about some of the ways in which government intervention can go wrong, because this becomes the crux of the argument and the issue that people have. Should the government intervene? Should the government not intervene? It depends in part on, first, whether the government has a role to play. And what we've suggested here in this example is they do. They do have a role to play. They can induce a better outcome. But the second question is, will they induce a better outcome? Can we guarantee that just because government has stepped in and says we're going to do something about this problem, that they're going to do it in the right way, that they're going to actually generate an improvement in the overall outcome for the people, rather than doing what might be easier or might be led in the direction of doing something by special interests who might lobby them for particular alternative interventions. Now, I want to turn your attention to another economist. Her name is Elinor Ostrom, lived from 1933, died in 2012. And she was the first woman Nobel Prize winner in economics in 2009. Now, she won the Nobel Prize for the following work. Okay, her work showed many examples of how communities themselves solved common resource problems completely on their own and without the government intervening in any way. Okay, and she went through and cataloged and characterized all sorts of different situations in history where common resource unsustainability problems and tragedy of the common problems were potentially there, but which the citizens of the area actually figured out ways to share that resource and make sure that it did not get depleted. So a couple of examples that she highlighted in her work is there's an area in Switzerland, in Tobel, which has a common alpine grazing land, which is shared amongst many, many farmers in the community. And they've got rules about how many cattle you can graze, what the grazing land can be used for, who uses it, how much. And those rules date back to the year 1483. They're ancient. They go way back in time. And it's a system that has worked and has helped prevent the depletion of the common grazing land in that particular area. Another example that she highlights in her work is irrigation systems in Nepal and how communities have kind of gotten together and set rules as to who's allowed to take how much water out of the river at a particular point in time. And they've made the community a system where they kind of get together. This becomes a kind of collective action where individuals sort of get the community together and say, hey, we've got a problem. We need to do something about it. They set up a system of rules. They set up a system of monitoring. They try to keep track of anyone who violates the rules. They might put into place certain penalties. But all of this is done at a much more local level rather than being dictated by some government that's far away telling the individual citizens what they should do in this particular circumstance. All right, so what we end up with here is I want to highlight the fact that this commons problem, the tragedy of the commons, is a kind of prisoner's dilemma problem. Because if you let everybody do what's in their own best interests, they actually end up with an outcome which is worse for everybody than it would be if they simply allowed some sort of regulation to take place. But here comes in the real debate that we can have, should have, and that should propel our discussions between right and left in this particular country and elsewhere. We can solve the tragedy of the commons problem with force, with government, with taxes, with regulations, or we can solve the problem with community cooperation. And what Ostrom's work demonstrated and showed is that there's lots of circumstances in the past where individuals were actually able to collectivize themselves, take collective action, to actually force people to do what would not be in their independent, immediate self-interest, but to do something that was good for the larger community itself and for the sustainability of a resource that they all are depending on. Ostrom not only showed circumstances where this happened, but her work also goes on to explain the conditions that seem to be necessary or needed in order for this type of action to take place. And one of the things is very similar to what Mansur Olson's work on the logic of collective action, which is smaller groups can band together and make decisions for themselves much easier than larger groups. The problem with larger groups is the free riding problem. The more difficult it is to monitor individuals who are going out and using a particular common resource, the more difficult it's going to be to get people to conform to those particular rules. But there's also going to be a lot of other elements involved. The sense that the community feels like they're, engaged, that they're identical to each other, that they've got a common heritage, that they've got common goals, that they're willing to work with each other as a community or as a group, that they have some solidity to that community, is going to be important to whether that community can work out a series of rules that everyone's going to follow or they're going to attempt to follow. So her work kind of shows situations where community cooperation can work, or at least where it's more possible to work. And in cases where the community simply can't band together and can't put that into place, well, that could be a role for government, where government can come in and regulate and set rules, set taxes, and try to adjust the outcome in that particular way. But the valid argument, really, economically, is government or not to correct for this particular circumstance or situation. The problem shouldn't be, does the situation exist? Is it a problem? It clearly has been shown to be a problem in many instances. But how to solve it is subject to discussion by different individuals. And you can argue reasonably that this problem can be solved without government. You can argue reasonably that this problem can be solved with government. Okay, and so you might have an inclination one way or another, but it's a point of debate and a point of reasonable argument for the future as to how to solve these particular problems. Okay, let me just highlight here that collective private action, which I just was talking about, involves community rules or norms that limit fishing or limit grazing. It allocates fishing rights fairly across the individuals, maybe limits how much fish individuals can come in. They've got to set up monitoring systems to make sure they can keep track of who's fishing the area, who's grazing the land, who's using the river for irrigation. And you have to come up with some way of enforcing the rules. What do you do? How do you punish people or leave them out of the system in some way if you discover that they're breaking the rules that the community has agreed upon? All right, and I mentioned this, it's more likely if the group is smaller rather than larger. Because free riding, and free riding here means, free riding is we've got a system of rules about how much fish each boat can catch per week, but some individual boats go out more times per week and try to bring in more fish. That's an example of free riding in this particular system. Or you set your cattle around the mountainside so nobody can see them grazing there. So you try to skirt the rules and try to break the rules. That would be the example of free riding in this particular circumstance.